Okay, so welcome back to part 2. So listening to the demo tape after I posted the video, I'm kind of skeptical about modifying this amplifier to a fairly simple Fender 5E3 Tweed schematic, but I'm trying to remain hopeful that there's a lot of good praise for the 5E3 circuit just due to its simplicity and its tone. So I'm hoping that this is not going to be an act of futility. But I kind of wanted to go over the schematic again. That was sort of a train wreck going through some of the different features of this amplifier. But kind of like I stated first of all, so this TP21 voltage here, this is 317 volts. And doing some more research into the tube rectifiers, I'm starting to realize that that's probably not going to be a possibility for this amplifier, because I didn't know this up until I did some more research, but the rectifier tubes reduce the output voltage. So you could feed that tube, say 300 volts or so, but the output's going to be about 220 once it's rectified and filtered. So I think I'm going to have to abandon that idea of a tube rectifier and just go with a normal full wave bridge diode rectification for this project. So, and then one thing I wanted to note here, so these two 100 ohm half watt resistors here, this is actually a artificial center tap, what they're using here. So you can see this header connector does not use the center tap, but the amp itself actually uses these two 100 ohm resistors to ground. And what this helps to do is reduces the imbalance between the two wires that go to the heaters. So if you have any imbalance in that line, then it'll drain to ground. Otherwise, if you don't, then it's going to induce a lot of hum into the amplifier. So that's something I'm gonna have to carry over to this design. So other than that, I've been looking into the transformer current requirements for the high voltage and for the filament winding. So we'll go over that now and see how I calculated that. Okay, so hopefully you guys can see this, and I hope you know that I actually did buy a camera tripod and a magnifying lamp so you guys can see all this stuff. So this is getting serious for me here. Okay, so what I'm showing here is this is the Crate 30 amplifier calculations that I've made for the filament winding and for the high voltage winding of this transformer. So what I'm trying to figure out is, what is the transformer rating of the power transformer in this Crate 30 amplifier? Because likely it's just going to have a part number on it. There's going to be no ratings. I'm not going to be able to find the specs online. So I'm trying to calculate what this amp would require in order for it to run properly. So at the top here, what I'm showing, this is the filament windings for the 4 EL84s and then the 3 12AX7s. So totaling those out, it's 3.94 amps just for the filaments. This is the 6.3 volt winding. For the high voltage, we assume 317 volts for the EL84 power tubes, and I went online. There's a couple biasing calculators that can figure this out for you. But at that voltage, we would expect around 34 milliamps of plate current for those tubes, and that's 136 milliamps. And then also for the 12AX7s, this is what I'm estimating, so you can do the same type thing. You can put in the plate current, and then it'll spit out a biasing voltage. So using that same calculator, we can figure out the plate current for these. And I noticed in the circuit too, the 12AX7 is a dual triode tube, so we have to calculate it as 1/2 on each side. So the calculator assumes that the 12AX7 has the same plate voltage for each side of the tube, but in the case of this amplifier, the voltage is different on each plate, so I had to calculate them separately. So all in all, the total filament current for this transformer, the 6.3 volt winding, is 3.94 amps, and the high voltage plate current is 180.5 milliamps for these tubes. So this is the more or less like the minimum requirement for this Crate 30 power transformer. So I know that if whatever amp I want to build is less than this or around equal to that, then I know that that transformer is going to work for it. Okay, so now moving down to the Deluxe 5E3. Here's the high voltage winding. So plugging in our max voltage of 317 volts. This is if I use the power transformer in this amplifier. The plate current will be about 64.4 milliamps for both. That's both tubes. And then for the 12AY7, it's 13.6 milliamps, and the 12AX7 is around 10.2 milliamps. So I use all the same Bison calculator online to figure this out. And then also for the filament windings, so we have the two 6v6 GTs, that's 0.9 amps, 12AY7, 0.3, and the 12AX7 is 0.3. So total for the Deluxe 5E3 amplifier, the high voltage winding needs to support 88.2 milliamps, and the total filament winding current is going to be 1.5. So the approximate margin we have, if we use this circuit and the power transformer we want to use out of this amplifier, we'd have about 92.3 milliamps of additional margin on the high voltage winding, and then 2.44 amps on the filament winding. Yep, so I think it's neither now or never. Less talk, more work. I feel like we've been talking a lot in this, at least in the first part of this video, so hopefully we can start actually doing some work on this amplifier. I'm a little apprehensive in completely tearing this thing apart just because I thought it sounded pretty good in the audio files that I uploaded in the part 1 of this video. But yep, the 5E3 Fender Tweed amps are kind of regarded as some of like the best sounding amplifiers ever made. So I have high hopes for it. It seems like a fairly simple circuit. I don't want to get too complicated into this because this is my first build I've ever done before. It's really the first time I've ever dove into this kind of a project. I've always wanted to do this. But yeah, so I guess it's time to take the back panel off of this amplifier. I want to take some bass measurements just to make sure they're in line with what I'm estimating for this amp. See if we can find any markings on it, try to learn a little bit more about it, and probably after that we'll put together a parts list, order some parts, and then we'll get into the actual build phase of this amp. Okay, so now I'm going to try to measure the plate dissipation on the EL84 power tubes. So what I've done here is I have my black lead connected to this point here. It's actually on this this resistor here is an R52. That's the label for it. So I'm connected on this side, and I'm measuring the voltage across this side of the winding, and I'm going to be measuring on this side of the winding. So I'm going to go ahead and do that right now. Okay, so now we're going to measure from J16 to J15. I've had the amp warming up for a while now. It's about negative 9.52 volts. Let's check that again. Okay, and I'm going to check the other side of the winding to from J16 to J17. It's negative 3.54. So kind of what I was saying when I first started this video, I thought one of the tubes was red plating. It's probably destroyed now, but we'll check the plate voltage on these EL84s, but you can see there's a gross mismatch, at least in voltage drop on that side of the transformer. So let's try to do some more digging into that and see why that's happening. Okay, so going from left to right here, this is V8. This is tube position V7, V6, and V5. So according to the schematic, The plate is on pin 7, so we're going to measure all the plate voltages for these output tubes now. So first tube is around 320 volts. Second tube is about 320 volts. Third is about 314. And 314 on this too. Okay, so now we should be able to calculate our plate dissipation for these power tubes. Alright, so one thing I forgot to measure here is we've got to measure the resistance of these, between the center tap and these two windings. So from J16 to J15, you have a resistance, oh my goodness, about 106.4. Okay, for the second half of the winding, this is from J16 to J17. We have a resistance of 74. Okay, so here's our plate dissipation calculations for the EL84 power tubes. So J16 is the center tap position of our output transformer, and J15 is one side of the winding that feeds the V5 and V6 EL84 power tubes. So we measured 9.52 volts at 106.4 ohms, and then the other side of the transformer was negative 3.54 volts at 74 ohms. So using those measurements and the plate voltage that we measured, we come up with 28.1 watts for V5 and V6, and for V7 and V8 we come up with 15.31 watts. So it averages out to 14.5 volts for V5 and V6, which is too hot, and then for V7 and V8 we calculated out to 7.66 watts, which is much too cold. So I'm thinking that potentially there might be an issue with the output transformer in this amp, so we'll have to check that out when we take this unit apart. So that might be something we need to purchase, and might be the reason why this amp had some issues to begin with. I could tell that there was something wrong with the amp. It seemed like it was running way too hot. I could feel the heat coming out of the vents, and I was looking at the tubes when the unit was running when I was taking these measurements, and it certainly looks like one of the tubes is red plate, and it's kind of hard to see. It's kind of buried in this amp. It's underneath. It's underneath over here. But I could kind of tell that there was something wrong with the amp when it was running. I could definitely smell a little bit of burning and some heat inside of there. So this might have something to do with that. So we have to take a look at that output transformer, but it appears that the power transformer is working fine. All the voltages on the plates seem to check out just okay, so it seems like the power transformer is okay, and that's probably the more expensive component out of this. So if I need to get a new output transformer, that's not the end of the world. So I've been doing a little bit more investigation into the potential issues with this amp. Kind of as we saw, the plate dissipation was much higher on one bank of tubes than the other. Just a quick observation, so the little viewing hole through this tube socket here, you can see the filaments. They're pretty bright, as you'd expect. Then when we get to this one, it's much dimmer than the other three. So I took some measurements on all the different tubes, the cathode to grid, the cathode to screen, the plate voltage, and then the screen resistor here. So I took the voltage drop across the screen resistors. All of them were pretty much in line, the V8, V7, and V6, but this tube here has a much higher voltage across its screen resistor, so the current leaving the screen is higher. So it was measuring in roughly 0.2 to 0.3 volts across these screen resistors, but this one is measuring about 1 volt, so it's about 5 times higher than the other three. So I'm wondering when we take this thing apart, we might see some issues with this tube socket or some other problems, so we'll have to keep that in mind when we're disassembling this amp. Well, here's where the problem lies with these Crate 30 Vintage Club amplifiers. These solder joints around the tube sockets crack, and they have to be reflowed after a certain amount of time. I think mine lasted probably 10 years before it had to be done, but you can see it's been repaired in the past. Looks like a couple of these solder joints aren't soldered completely. Probably the copper on the trace was removed, so they had nothing to solder to. But I checked this out. This is pin 6 of an EL84, which is an unused pin, so that shouldn't be much of an issue. And the V5 socket is this tube here on this side. And none of these solder joints look bad to me, so it's hard to say what the issue is with this tube side. Some of these solders aren't the greatest, and they might have been creeping over to another trace or something. When it starts to warm up, you might have some leakage current going on somewhere, or some ground contact, some partial grounding. It's hard to say, but yeah, this is kind of the issue with these PCB board systems. They just don't really take heat very well in the solder joints. So yep, just wanted to show that to you guys. Okay guys, so here is the completed chassis for the Tweed amp build. See, I have all the holes drilled, so I'm going to be pop riveting the terminal strips in later. But this is going to be the mount for the power transformer, and this is from the Crate Vintage Club 30 amplifier, which we reviewed in part 1. These two holes here are for the full wave rectifier bridge, and these other smaller holes all the way across here are for more terminal strips, and then these two larger holes here are going to be for the output transformer. I left the space open for a filter choke, and I looked up online the appropriate choke size for this amplifier, and I left enough space where I can install it to where they're perpendicular to one another. You want to do that so that they don't interact with one another at the magnetic fields that are generated in the transformers. But yeah, so word of advice, so I used 16 gauge steel on this build, and this is extremely difficult to bend. You can see I kind of junked up some of the edges on here, which it doesn't look very good, but this is all going to be hidden by the amplifier, the wood on the amplifier chassis. So most of this won't be seen, and I'm hoping a lot of this is going to be covered up after I paint it. But I got some hammered paint, so hopefully it will hide some of these gouges, and I filled in some of these with JB Weld. So I got some JB Weld stickers from the automotive store, and I filled in some of these larger gashes so that will look smooth once it's all painted. But you can see I kind of went to town on this edge here. But if you're going to be using 16 gauge steel, definitely cut these panels out separately, or if you have a professional bender, or just have a metal shop bend it for you. But I wanted to do all this myself. But I would, if you're using a 16 gauge steel, definitely cut these panels out separately and fixture them up so they're 90 degrees, and you get a perfect rectangle when you're done. But this stuff is extremely difficult to build, to bend. I had to use an acetylene torch with a small sledgehammer to try to even make this stuff to move at all. So honestly, if you're going to be using this, I wouldn't even recommend 16 gauge. Maybe like 18, maybe even 20. 20 is pretty thin. Maybe start with like an 18 gauge. That might be a good compromise. But if you're going to use 16 gauge, definitely cut the panels out separately. But so this is going to be our fuse, on-off switch. Standby, here's the pilot light hole, and here's for the controls. There's I think this is the depth, speed, tone, and the 2 volumes. This is going to be for the bright and normal channel input jacks. And the back side here is for our power cord. This is for the 6V6s. This is for output to our speaker. And this is the Tremolo pedal. And here's for the 2A 12AX7s, and here's for the 12AY7 preamp tubes. So yeah, what I did is I started off with a single sheet of 16 gauge steel, bent these 2 main pieces here, so this was one piece, bent these edges, and then welded on end caps on the side here to make it entirely enclosed. And on the back side of the wood panel of the Crate Vintage Club 30, there's actually a sheet of aluminum. So I'm hoping to make some kind of like a Faraday cage to get some I'm going to leave this metal bare here, and this hopefully will come in contact with that metal sheet to make a complete metal enclosure to keep any kind of like EMI or any kind of interference from interfering with the circuit. So I should get the parts pretty soon, but essentially it's going to have all of the terminal strips mounted inside here, and I'm just going to do point-to-point wiring that way. But yeah, I would certainly recommend and suggest going with something a little bit thinner. I've got easily 10 hours into this minimum, and I painted it once, and I used some printable labels on here, and it didn't turn out very well, so I'm using like a darker paint so it'll hide some of the label edges when I put them on later. But so I had this painted at one point, and it's all been stripped again. It's been sanded down to a 400 grit sandpaper finish, and then wiped down with mineral spirits to get all the grease and dust off of it. So I'm going to start painting it now, and I'll show you guys the finished product afterwards. But I think it'll work. You know, it won't be perfect, obviously, but you know, this is, like I said, this is my first build, my first time going into this kind of a project. So I think it looks okay for you know, do-it-yourselfer, and you know, I guess we'll get some pride in doing this all myself. But yep, just wanted to give you guys an update on this. So just wanted to show you guys the paint selection for this amplifier build here. So first I just went to Home Depot, got some spray can paint. I have a self-etching primer. This is meant to be put on bare metal and give it a good robust surface for applying paint to. So we'll start off with that. And then I went and got this hammered Rust-Oleum, kind of like a brown metallic hammered finish. So the hope is to kind of cover up some of these blemishes in here from that sledgehammer. It didn't do me any service when I was building this, but you know, hopefully it'll help hide some of that stuff. Kind of like I said, I got some JB Well in some of these areas, so it looks much worse in on the video here. But I can assure you, it's nice and smooth. So this won't even show. Some of this stuff won't even show up after it's painted. But then after that, so we'll paint it with this hammer finish, and then we'll put the labels on. So the goal is to use this metallic brown hammered finish, and then we'll use cream colored labels. So I think that'll be a nice contrast. So you have a nice dark brown metallic with a cream colored labeling on here. So I think that'll look pretty sharp. Then after we put the labels on, then I'll cover everything in this crystal clear enamel clear coat. Do a few coats of this to give it a nice durable finish on top. Okay, here's the finished self-etching primer. So we got all that done, and this has been sanded to 400 grit on all sides. You can kind of see it. I got some of the dings there from the hammer. I got some high build primer, so we're going to do that next, to do a few coats of that, and that should help smooth out some of these panels a little bit better. Looks like the bottom isn't too bad. Looks okay. You can kind of see in the light. It's a little bit wavy in areas, but you know, it's gonna do the job. It's gonna hold the tubes, and everything's just fine. So yep, so we're gonna do some coats of filler primer next, and we'll see how that turns out. Alright guys, so here's the somewhat finished product here. So we got a couple coats of etching primer on here, and about 3 to 4 coats of filler primer. It didn't really fill in a lot of some of the hammer dings up here as well as I would have liked. But it filled in, you know, most of the dents and dings that were on the main control panel here that you're actually going to see in the amp. So pretty much this whole outer edge is going to be covered by the amplifier cabinet anyway, so it's not going to be that much of an issue. But I think it came out pretty good. I had to drill a couple holes for the output transformer lead, so I added those in there. And here's the back side. So I think overall it turned out to be pretty good. I got parts coming in tomorrow. I checked the UPS tracking. It's coming here tomorrow. So I'll be pop riveting in the terminal strips here in these holes. I'll probably give it another couple coats of primer, and then we'll start painting it with the actual brown metallic. Then we'll start fixing some labels to it. Then we'll clear coat it, and then we can actually start the actual amplifier build portion of this project. So, yep. So thanks for watching part 2, and hopefully we'll see you again in part 3.